In this tutorial, we will learn how to apply market survey weights in R. Another way of saying this is weighting market survey data. So if you have RStudio open already, go ahead and go to File, New File, RScript, and this will open up your RScript editor. In other words, it's called your RScript file once you save it. And let's make a quick note here using the hashtag that we are applying market survey weights in R here. So this is the focus of the tutorial today, and specifically we're going to be applying sample weighted means. Now, why do we weight our market survey data? Well, imagine that you have more than one source of market survey data, maybe 2 or 3 from different vendors, which is usually a wise call because any vendor's data is going to have no data are going to be perfect, and sometimes there might be issues, or there will always be issues related to sampling error and things like that, as well as the rigor that different vendors apply to collecting the data. So what we want to do often is to apply more weight to certain surveys and their data than to others. And so there's different ways that we could do this. We could do a judgment call in which we assign different weights more holistically based on our perceived rigor of each survey vendor's approach. Alternatively, we can calculate sample weighted means, and we can calculate the sample weighted means based on the number of organizations that that a survey used to actually pull its survey data for a given job, or we can use the total number of people who are working in a specific job and use that to weight our average. And so in this case, we're going to be focusing on sample weighted averages and how to calculate them, in other words, sample weighted means. And the process I'm going to show you could apply to both the process of weighting by the number of organizations or weighting by the number of employees. So the next thing that we're going to do is let's set our working directory. So let's tell R where our data are actually going to live here. And so let's use the setwd function from base R, and then in my H drive and my R workshop folder is where the data file lives that we're going to use for this tutorial, at least in my case. You've saved it likely somewhere else, so you'll need to put your own working directory path extension there. And so I'm going to click Run there to access my working directory and to note that set my working directory that it's my R workshop folder in my H drive. Alternatively, you could go to Sessions, Set Working Directory, Choose Directory to do that through dropdowns. The next thing we need to do is read in the data, and we're going to be using the reader package, which is part of the Tidyverse set of packages, or the universe of packages from Tidyverse. And if you haven't already and you haven't installed the reader package, go ahead and use install.packages function from base R and put the name of the reader package here, which is all lowercase without E between D and R. Put that between quotation marks as the sole argument within the install.packages function. Now I've already installed this recently, so I don't need to update it, and I don't need to install it for the first time, obviously. So I'm going to jump straight to the library package here, or the library function here, and type in as the sole parenthetical argument the name of the reader package here. And what this will allow me to do is access the functions within the reader package. So let's click Run there. So now I have accessed the reader package here, and specifically I want to use the read_csv function from that reader package to read in our data. And so we need to state what we'd like to name our data frame object as when we read it in. So what object are we going to assign our data frame to? Let's call it MD, lowercase m, lowercase d to stand for market data here. And again, we'll use that read_csv function. And the name of the data file that we're going to be working with is market survey data.csv. And this lives in my working directory folder that I specified up here. And note there's a capital M for market, a capital S for survey, a capital D for data, no spaces. And make sure you include that .csv function and surround the whole file name there with quotation marks and use that as a sole parenthetical argument here in the read_csv function and click Run. So let's click on our global environment here and the name of our MD data frame object that we just read in. And so here you'll see we have these different variables in our data frame object. We have job_ID. This is the unique job ID that's associated with each job title. And so the next variable or field is our job_title. And here you can see the names of the different benchmark jobs that we're referencing here and for which we've gathered market survey data. And then survey underscore 1, 2, and 3 represent 3 unique market survey data sources here. Okay? And so these values within each market survey data source represents the hourly pay rate for these non-exempt job titles here. And then when you see these variables, SS underscore survey, SS underscore survey 2, SS underscore survey 3, these represent the sample size for these different surveys. And so for this sake, let's imagine that 101, this value here, represents the number of employees whose data was provided across organizations to come up with this estimate of the median hourly pay rate for the packaging operator job here for survey 1. Okay? Just as easily, we could have said this represents 101 organizations that were surveyed in order to come up with this median hourly pay rate for the packaging operator here. So the same goes with survey 2. So SS underscore survey 2. So sample size underscore survey 2 here, 35 employees total. That corresponds to this hourly rate of $14.51. And for SS underscore survey 3, so sample size for the survey 3 is 13. So this is 13 employees here that corresponds to this value of 13.98. And so with a sample weighted mean that we're going to calculate, or set of sample weighted means, what we're doing is coming up with an overall estimate of our median hourly pay rate for, let's say, packaging operator and then machine operator and so forth and so on. And we're going to weight the different values provided by these surveys. Instead of just taking a standard mean here, we're going to weight by their sample size. So because the hourly rate from survey 1 is associated with 101 employees, which is much greater than 35 and 13 from the other 2 surveys, this means it's going to receive greater weight here. So it'll carry more weight, and you'll see how this works out in a second. Okay, so the next thing we're going to do is calculate sample weighted means. And this will be a little bit, this will require a number of different operations here, but it requires just one step. There's different ways that we could do this mathematically, and all of which require just basic arithmetic. There are some ways you could do it too that would involve matrix mathematics. You can use whatever approach you need, but the math is relatively simple. There's just different ways we can get to the same solution. Okay, so what we're going to need to do first is come up with, well, first we need to state what is the name of our data frame object. Well, it's MD. And what do we want to name this new variable that we're going to create that's going to represent the weighted mean for these jobs? So it'll include the new kind of final estimates of the sample of the median hourly pay rates for these key benchmark jobs that we have in our data frame here. Now, I should note that before you do, if you do need to age your data, make sure you do that before you calculate the sample weighted means here. Okay, so if you do need to age your data, and I'll make a little note up here, if necessary, age data prior to weighting the market survey data. So make sure you do that prior to this. And if you want to learn more about that, check out the tutorial called Aging Market Survey Data in R. Okay, so back down here, we've got our data frame object. We use the $sign to attach our data frame, or rather to attach a variable to our data frame object. So let's come up with a new name for a variable. Let's call it the weighted underscore mean with a capital W and a capital M. So this will be the new variable that will be attached to our MD data frame here. And this will contain our vector of the sample weighted means that we're about to calculate. So let's use the left-handed arrow here to note that we wish to assign values to this. And so what values are we going to assign? Well, bear with me here, but this will require, because we have 3 surveys here, and we have 3 sample sizes associated with those surveys, we need to carry out this process. It's a little bit lengthy here in terms of the amount of space it takes up, but the math is relatively simple. And so the first thing that we're going to do is we're going to create broad set of inclusive parentheses here. Okay, this will be our numerator that we're about to specify here. And so what we're going to do is create then another set of parentheses within this. And you don't actually need to do this because of the order of operations in math, but this will make things a little bit cleaner by adding this second set of parentheses, and then you'll actually have a third and a fourth set as well, as you'll see in a moment. Okay, so the first thing that we're going to do is specify the name of the data frame, and then the $ followed by the name of the first survey. So this is the first market survey, which is survey_1 times name of our data frame, and then the sample size associated with that survey. So the number of employees from which the estimate, the median hourly pay rate, was estimated for that particular survey source. Okay, so we just have a simple multiplication here. The actual, so it's the median hourly pay rate in this case, and you could also apply the same process to the 75th and the 25th percentile estimates as well. And so here we have that pay rate times the sample size used to estimate that pay rate. So to make things simple, let's go ahead and copy that, and let's add, and then by adding a plus sign, and then click paste. And now we're just going to do the same thing, but let's just edit this so that we're going to focus on the second survey and the sample size associated with that second survey. I'm going to add another plus sign, and then because I've run out of space here, I'm going to hit a return or enter here, and then I'm going to paste again. And this time I'm just going to edit so it's survey_3 and then SS_survey_3 here. So this is the survey, the hourly rate for survey 3 times the sample size associated with survey 3 there. Okay, I'm going to add a space here for clarity, and then do, actually I won't add a division there on that side of the parentheses, but what we have here is the numerator that we're going to use to calculate the weighted mean here, the sample weighted mean. So the next thing that we need to do is we need to use the divided by, the forward slash sign here to indicate division, and then we need to specify our denominator in this fraction here. And so the denominator, let's go ahead and do parentheses here. The denominator is just going to be the total sample size. So the total sample size across all 3 surveys and for each job here, okay? And so first we'll copy this. So the sample size for survey 1 plus, and then copy the sample size for survey 2 plus, and then copy the sample size for survey 3 here. Okay. And so now we have a fraction here that we've specified. This is an equation. Here we have the numerator, which again is the median hourly pay rate for each survey times the sample size used to estimate that from the survey. And we have that for all 3 surveys. We're adding all those products up here and then dividing by the total sample size used across the 3 surveys for a given job. So you can imagine behind the scenes, we're doing this for each row in our data. Okay, so we're applying this equation to each row. So first it'll be applied to the packaging operator, then machine operator, and so forth to estimate the sample weighted mean for the median hourly pay rate for each job there. Okay, so let's go ahead and run that script there. Okay, so you can see blue text usually is a good sign here. And let's take a look now at our data frame object. We should see a new column. Yes, now we have the weighted mean here. Okay, so the weighted mean is 14.19 for the packaging operator here. Okay, and it's 15.90 for the machine operator. And so here we get an idea of, this is kind of the final estimate you could say for what is the median hourly pay rate that we're going to use, or what we're going to use for a median hourly pay rate in terms of referencing the external environment, and if we want to assess external equity and so forth, and see how well are we paying relative to the market for these jobs, these key benchmark jobs here. Okay. All right, so one thing that you'll notice though is that was reported to our new variable has more than 2 decimal places. So let's use the round function from base R to adjust for that. And first what we're going to do is we're going to copy just the name of the data frame, $, the name of our new variable, which is weighted_mean, and that left-handed arrow operator. Click paste here, and then to the right of it, we'll use the round function from base R. And the next thing that we're going to do is we are going to copy the name of our data frame, $, and the name of our new variable. And this will go as the first argument in the round function. As the second argument, indicate the integer. And this is the integer value you enter here is the number of decimals or places after the decimal point. So here we want 2 because it's fairly conventional with currency and specifically dollars to include 2 decimal places after the 0 to round to that. So let's go ahead and click run there. Let's peek at our data frame object again. And here we go. We have now rounded to 2 places after the decimal point here. And so now we have our vector of weighted means, and they correspond to each of our key benchmark jobs. So there are ways in which you could simplify this into a single step, or rather not a single step, but you could use matrix algebra. You could create a function and so forth to do this in a more automated fashion if you do need to do this multiple times for multiple different sets of data. But this is meant to show how you do this, what the math is behind the scenes here. We are applying market survey weights in R, or in other words, we're weighting market survey data. So this wraps up the tutorial on applying market survey weights in R.